All right, my name is Phillip Kramp. Unfortunately, as you may have just heard, Grimm is not here. He cannot schedule things properly and is out in San Diego. I will be giving this talk today on basically how to secure your OpenShift. It's not too different than securing any of your other systems or anything. It's just a new technology, so most people aren't too familiar with how to secure your Kubernetes cluster and all that. So there's me, senior consultant at Red Hat. Primarily in the public sector, so mostly supporting government customers around the country with their various, mostly OpenShift, but also Ansible and a few other of our products. Chris was on the consulting side as well. He recently switched to become a sales architect, primarily supporting the Army. All right, today we're going to talk about kind of the overall state of security, how to harden your OS, which is kind of the first primary. Hopefully most people are familiar with that, so we can kind of skip through that pretty quickly. Then kind of why you want to do container signing, certificate management, kind of how OpenShift handles that. Using your secure pipeline to kind of build a better image and limit things running in production, and then multi-factor authentication. So, developers frequently just want to develop their code. They don't really care about security, although, as we'll get to in a minute, they know they should, but they frequently have their own deadlines. They need to get code out, they need to get objectives done, and they just generally don't have time to care too much about security. Security thinks you can just encrypt it super well, and then no one can get into it. Everything's good, but you have to kind of balance that with usability. Doesn't matter how secure it is if no one can or will use it. And then DevOps frequently is fighting fires one at a time. They don't have time really to do root cause analysis frequently. It's something that a lot of companies need to do a better job about. So this is a report from about a year ago. I want to say it was fall 2018, might have been summer. But 33% of the people that were surveyed had reported a web app breach in the last year. 48% of the developers didn't think they had enough time to work on it because they have other priorities, they got other deadlines to meet. And 80% of everybody, security, ops, developers, agreed that everyone should be playing a part in it. They just don't have time or priorities. So people know it's a problem. We just have to get management on board to try to fix it. Yeah, and part of the thing, one of the most basic steps is compliance. By keeping your apps, dependencies, which is usually a big one with development, keeping those all up to date. 80% of attacks use vulnerabilities that are known. Most of them don't use 0 days. Most of them don't come up with their own attacks. There's something that's been patched frequently for months or years, and people just never got around to it. Most of the ransomwares that you see at hospitals, municipal governments, the big one last year with the credit monitoring, those are all vulnerabilities that have been out for months that people just never got around to patching. So that's why the first thing, whether you're doing containers, Kubernetes, or just your OS, you need to harden it. So one of the big ones is OpenSCAP. DoD uses it, lots of federal agencies use it. It's all out there for free. NIST helps write the guidelines for it, and everyone can go through, figure out basically some settings that are good general guidelines. You usually can't apply every single one as strict as they want, but you should at least know why you want to leave this vulnerability open, or not necessarily vulnerability, but this permissions level high, or you need this service to run. So out of the box, pretty much all of our Red Hat products, because we do support so many federal customers, as well as financial institutions and stuff, you can select a lot of these as you're installing the operating system and just have it at a base hardening already. So you got the PCI DSS, which is the one financial institutions use. You got the DoD DISA-STIGs. You got the criminal justice systems. And you can kind of select all these out of the box. Go ahead and start it from a non-goods point. We've already tested it. It's supported. You don't have to worry about breaking support. If you run into issues, you can open up tickets with us, get some help. So you can also use Ansible to help harden your systems. So using things like this, which will generate the fix and run it through, and you can go ahead and harden it in kind of an automated and repeatable way. And some of the icons aren't showing up. Oh, there they go. All right. So one of the big things with DISA and STIGs and all that, there's a webpage, AnsibleLockdown.io, which has a lot of the playbooks out there. A lot of them are under the MindPoint group. For some reason, that's the group that we usually work with. So they have the official Red Hat content for kind of securing your systems, locking them down, and being able to apply them in a consistent and repeatable manner. These are some of the common baselines that are out there that people frequently use. Kind of same thing we talked about before. So one of the things that we've been doing a lot with our customers, and more people are going to, is kind of writing your infrastructure as code, and which is kind of creating sort of security as code. By having repeatable processes that are push button, you don't have to worry about this person making a typo. Maybe this person wanted to put these security settings on, but this other person didn't think they were necessary. So by having Ansible playbooks, or however you like to do it, you can basically have a push button deployment. You put some configurations in place, spin up your new servers, add them to the VLANs, whatever you need to do in kind of an automated, repeatable fashion. So, and along with that, one of the big things that a lot of people still don't like to do, because it does take longer to set up, is doing your RBAC, your role-based access control. And these are the same things you need to do on servers, you need to do on your clusters. Basically, set up your groups. It'll take a little more time, especially when you only have a few users. You may not think you need the groups. But frequently, when you start onboarding people, it accelerates rapidly, and you don't have time to go back and figure out, all right, how should we set up these groups? What do we need to do? So by setting them up early, set up your permissions, you ensure that you know what permission sets everyone have. You're not doing one-offs. All right, this guy's a cluster admin, this guy's a viewer, this guy's an auditor, and then having to remember what everyone has. Another big thing, especially with containers and Kubernetes clusters, is quotas and limits. One of the things you can do in OpenShift is say, I want this project to only have this much compute, this much memory, storage, or this user. And one of the frequent problems people have is either intentional or unintentional, basically DDoSing themselves. You can take up all the resources and not even realize it if you don't set up your quotas and limits ahead of time. And take yourself offline. So, one of the things that kind of helps with limiting what's running on your system is doing digital signatures on your containers. So kind of the same thing Microsoft has done with the updates and drivers and many other vendors. By signing everything, it doesn't prove that it's secure, but you know where it came from. So you know it wasn't some side-loaded project. You know it isn't a rogue application or anything running on your cluster. And kind of one of the ways that most people do that is you have your built image, either build it yourself. So we do build the image a lot of times with an OpenShift, or let's say you go out to Docker Hub, registry.redhat, or any other Docker container registry. You take that, add it into the OpenShift registry. At the same time, you can do an OpenShift API call, kind of sign it with the internal signing certificates that you set up. And it comes back down, pulls the image to your signing pod. It'll spin up a new pod just to sign it. Pulls that image over, signs it with the signing key, and then puts it back in the registry. So why you care about that is in the traditional path, you have frequently with the DevSecOps pipelines, you've got the developer, he does his stuff, shoves it into the registry, it goes over to test, goes over to prod. And there's no guarantee that the developer didn't just go ahead and push it all the way to operations. So by signing it, you add in this new path where it gets signed, and then you can restrict your OpenShift cluster so that only stuff signed for prod runs in prod. So someone can't just run a rogue application. You can't just skip a test process, because then you restrict who has those signing keys. Not just anyone can sign. They have to go through whatever process you set up, and that kind of helps protect your production. So kind of just overall how certificates work. Is at a high level. You got your root CA. Generally, those aren't connected to anything. General best practices. People spin up a root CA, spin out a couple sub CAs, shut it down, disconnect it from the internet, from everything. That way that doesn't get compromised, because if someone compromises your root CA, they can generate all the sub CAs and everything they want. So you keep that one offline in case you ever need to revoke any of the sub CAs. And at that point, if you do, you spin it back up, revoke a sub CA, spin up a new one, it knows what's revoked, and shut your root CA back down. So you can even have multi-level sub CAs that are signing your different certificates, as long as they have that signing authority. So in OpenShift has its own internal CA that issues all of the certificates continuously on all the running pods, as well as your nodes, your master node, your infrastructure nodes, and your compute nodes. And these are generally, they're only good for, I think by default, it's either 72 or 96 hours, and it issues a new one. So one of the thoughts behind that is, as it is its own signing CA, by quickly revoking those certs and everything, you kind of keep current with what's running out there, and things don't expire. And then as long as you trust the OpenShift CA, then everything that it issues is trusted as well. So that stops those pop-ups being popped up. Do you want to trust the cert? And any of those other issues. So there's a couple ways you can do that. You can have, if they trust it, a lot of federal agencies and others won't, but you can have them issue a signing cert to OpenShift. If not, for example, one of my clients, we have our IDM issue a signing cert to it, and then they trust our IDM, but it doesn't have an official signing cert for the agency. So one of the big things that people are using containers in general to deploy quickly is pipelines. You can do it kind of in more of an automated fashion. You can have all your different pieces tie in. You've got your pipeline delivery, so frequently people use Jenkins for that, or their preferred builder. And then usually the way we have it running on top of OpenShift as another container. And then that can be running on top of whatever your infrastructure is, whether it's Red Hat, bare metal, whether it's AWS, Google, Azure. And then you can lock all that down, kind of like we were talking about before, using your OpenSCAP, your SIG settings. And then you've got your Ansible automation, which can run across all those levels, kind of help do that infrastructure as code we talked about, as well as automating the process. So the first thing you usually have is you need your source code repository. In our case, we're going to be using Git, and you're going to build your app. So once your app's built, it gets sent over to do some quick unit tests. Those unit tests can be anything you want. They can be either an automated approval method. So let's say you want to check, make sure 1 equals 1. And as long as you trust that, you can just have it automatically check and pass it on to the next level. Frequently, you kind of want to start off with more of a manual approval process for 2 reasons. One, you want to make sure all of your checks are doing what you think they are, and kind of validate that you didn't accidentally put 1 equals 100 somewhere, and you don't want that accidentally making it all the way through. The other is it kind of helps build the trust for management. Frequently, management doesn't trust automated tests all the way through when they're used to having a test team that may take a week to go through this. So by proving it, you can slowly start turning these into automated gates and make this from maybe a week, 2 weeks, some cases a month process, to minutes or hours. So from there, usually you do static code analysis. Same thing you want to do for your app running anywhere, whether it's a container, whether it's running on a bare metal server, running in the cloud somewhere. You want to make sure your code is secure. So you can set up gates again for this. There's plugins for Jenkins for Fortify, Cast, all of your main static code analysis tools that can go ahead and automatically ingest the code, analyze it based on the thresholds you set, so many criticals, the code quality you may care about. You can check all of that, make sure there's enough unit test documentation, and then based on that, either make it a push button to start or automatically pass or fail the build. If it passes, you can go ahead on, move in, store it into your artifact repository. So frequently you got things like either Quay, Nexus, JFrog Artifactory is another big one. So you're going to build your image and store it up there so that you have something to reference for your test and development and production for later. So once you've got your container, you can go ahead and then also do a container image scan. So there's a couple different main tools. You got Clair, which will scan containers, Black Duck, Twistlock, as well as JFrog X-Ray are the main ones. But basically, it's whatever you guys prefer. You just plug it into your pipeline. Almost all of these either have APIs that you can write your own plugin for Jenkins, or even have Jenkins plugins. And same thing, you can do an automated check, make sure there's no vulnerabilities on the container image itself. So your source code may be good, but let's say you're building on an old version of MySQL that has a vulnerability in it. This will check and make sure that the whole thing is still secure. And make any reports or vulnerabilities. And then you kind of do the same thing with the gates. If there's too many vulnerabilities or they're too high of a level, let's say they're criticals, you don't want to have any of those, and no more than one high. And you can go ahead and do that. And the thing you can do at the same time as well is kick off an email from Jenkins or the pipeline that says, hey, we promoted it, but these are the findings, you may want to look at it. Make sure you get them scheduled into your sprints or whatever method you guys are doing and fix them.
I have a question for you.
Yeah.
So for container vulnerability scanning, how is that actually done? Is that just scanning like a configuration file, or is it actually putting up that container and then an actual scanning?
So the way most of them work is it actually spins up the container and scans it, or ingests the container and kind of analyzes the binary bits.
Okay.
So it's usually one of the two.
Gotcha.
So you do have the Docker files though. So you can do some analysis on that, but usually these don't do that.
Okay.
That's more kind of how you want to set up the container. Gotcha. So one of the things OpenShift won't allow you to do by default, you can force it, is we don't allow containers to run as root. Okay. That way you can't just pull down anything and run it or install anything. So most of these containers, for example, some of them may not even have VI. They probably don't have wget, they don't have your compilers on them. And we don't want them to be able to add it. If they need to add something, they should go back and build a new image. So, kind of more scans for compliance if you have a customer or you care about that. So you made sure there's no vulnerabilities. Now making sure that your MySQL container, for example, is running with the right permission sets that the STIG requires. So you can, again, you're ensuring your compliance, having a good baseline, limits your number of exposures and vulnerabilities in production. So at that point, that's when you can start doing that deployment that we talked about earlier with the test to the QA to prod. Is you can go ahead and have this create your deployment. It's already passed everything, whether you clicked yes, go to the next gate, or it's automated, doesn't matter. Once you get to this step, it starts moving things through to the next level. So then you promote it. Frequently, the way people do it is, especially if they care about the security, is like we talked about, and sign your containers. So your QA cluster can only run images that are signed by development. Your production cluster can only run images that are signed off by QA. So that kind of ensures people don't skip steps here and limits what gets run. So one of the things is you kind of want to continuously scan your containers because as we talked about, if people can run whatever they want, they may for example, in October last month, there was a graboid cryptojacking images that were found on Docker Hub. That if people didn't know better, they could go pull down this MySQL image they thought was clean. It had a crypto miner hidden in there. You kind of want to continuously scan for your images, make sure you didn't pull down one of these images. Another problem is even before people had baked-in ones, people would find those containers running as root and go ahead and pull down, just do like a wget to a website, start up a project running on the background of your container. You think this is only hosting your database, it's got a crypto miner in the background also eating up your CPU and resources. So by locking down who can run as root and continuously scanning your containers so that there's not rogue containers, you kind of keep an idea of what's running in your system. Because just like VMs, when people spin those up, generally these days people have process of tracking how many VMs are being used, what the resources counts are and everything. Containers should be the same, but since it's newer, a lot of people kind of don't really fully understand it yet. But you need to make sure that there's not rogue images running on your systems. So one of the things that comes up, especially in federal space, is your authentication and authorization. So with OpenShift, these are kind of decoupled processes. So you can have the authentication service call out to a separate authorization service. And that's how we frequently tie in things like two-factor authentication with smart cards and things like that. And just go ahead and offload that to whatever existing infrastructure you have in place. So with your typical authentication piece, you have the user sign into the web console. That go ahead and passes it on via SAML proxy on the back end to whatever your identity provider is, whether it's AD, LDAP, or some other source. The user then their credentials get passed over there. It checks to make sure you are who you are, and then sends it on back, and then you get into the system that way. So you can go ahead and offload that piece outside of OpenShift, handle it the same way you do the rest of your applications, services, and not have to change anything there. So with authorization, kind of the same thing. Your user or administrator is logging in. It's getting your group syncs. So LDAP, the way we frequently have it set up at the moment, is the users and groups get copied over into the internal groups and users on OpenShift, and it continuously syncs those, usually using Ansible Tower jobs to make sure everything stays up to date. And then you can use your RBAC to limit who has what permissions, what they can do. Are they allowed to create a new project? Are they allowed to start a project? Can they add users? Do they have quotas limits? Can they change those? Can they change the parameters on your application? So one of the big things, of course, with containers is the scalability. So you can quickly scale up from 1 pod to 100 pods. But you might want to limit who has that authorization. With two-factor authentication, generally what people do is you kind of use that same authorization model, and with one additional step where it calls out to your smart card server issuer, certificate issuer, validates that you are who you say you are, that you are Phillip Kramp, your cert is still good on the smart card, and then it goes ahead, checks what your permissions are, again against the LDAP, and your groups and role-based access. So one of the things, of course, with this is that works for the web, but a lot of times, either by choice or because there isn't a nice web GUI command for it, you need to do things via the command line, so via the OC CLI. And one of the common things we see people using if they're using two-factor for SSH is there's PuTTyCAC, which is out there for free. You go ahead, set up your PuTTY authorization, so it can understand your smart card, pass that on to the server, and get you in via SSH console, so you can do those OC commands by hand. So there are a bunch of projects and stuff out there to help you. We generally try to keep all of our stuff, if we can, and aren't limited by the customer. We put it back up on GitHub so people at Red Hat as well as the general community can use it and learn from it. So you've got the GitHub official, or Red Hat official, as well as the OpenShift repositories that have your LDAP group syncs as well as your SAML playbooks. There's a nice Red Hat article as well as a blog post on how to set up multi-factor authentication. As well as redhatlearning.com has kind of like a forum style group. So there's a bunch of people from Red Hat as well as general community users. If you have questions, you can kind of go get some community help if you don't have support. So one of the big things for federal especially is FIPS. One of the things that may be kind of weird if you haven't worked much with government is 140-2 says you have to use a supported and approved encryption algorithm or plain text. So you can't use a bad encryption algorithm. It has to be validated and approved or plain text. And the reason for that is they want you to know that you're using plain text rather than having a false sense of security that you're using something that's really vulnerable. So you can't do 3DES on your code or anything. So far, OpenShift has not supported FIPS, but tentatively it's on the roadmap for OpenShift 4.3 that should be coming out by the end of the year. So that's for OpenShift itself. So one of the big things is the OpenShift container storage, which kind of allows you the dynamic provisioning and growing. You just say, hey, my container needs 5 gigs of space or needs 100 gigs of space. The part that allows you to dynamically allocate that space, reclaim it, use it as you need is the OpenShift container storage. They haven't definitively said whether or not that will be in the roadmap. So that may be something you may have the UI with FIPS, but not turned on your storage nodes. So these are some more of the resources we mentioned. So you've got the MindPoint lockdown group that I mentioned for getting some Ansible playbooks, helping lock things down. There's the Compliance as Code project that helps you kind of get some baselines for setting up your applications to be infrastructure as code and supplied. The OCP multi-factor authentication, that's the blog post I talked about. That kind of goes through and also references those GitHub projects. And Secure Factory, Software Factory, kind of goes through helping you to write secure code using the pipeline, getting those gates. So, that's about it. I think I covered all the parts Chris was going to, but since he's not here, I may have missed some stuff. So if you guys have questions, we've got plenty of time. We can go back to any of the slides if you have a question about a particular process. All right.
Yeah.